I've got a common mistake in Go, working with Matt Ryan. I was going to save that for the unpopular opinions, but I think it's a popular one. So far, only David Hernandez seems to be able to stick around and hang in there.
Multiple times, too.
Don't use his name in vain.
I don't. I love David. Yeah, he deserves all that he gets for putting up with you.
I love it. I've never had banter happening and insults concurrently for both Johnny and Mark at the same time. Speaking of concurrency, here's another one.
Big thanks to our partners Linode, Fastly, and Launch Darkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by Launch Darkly. Get a demo at launchdarkly.com. This episode is brought to you by our friends at Cockroach Labs, the makers of CockroachDB, the most highly evolved database on the planet. With CockroachDB, you can scale fast, survive anything, and thrive everywhere. It's open source, Postgres wire compatible, and Kubernetes friendly, which means you can launch and run it anywhere. For those who need more, you can build and scale fast with Cockroach Cloud, which is CockroachDB hosted as a service. It's the simplest way to deploy CockroachDB and is available instantly on AWS and Google Cloud. With Cockroach Cloud, a team of world-class SREs maintains and manages your database infrastructure so you can focus less on ops and more on code. Get started for free with a 30-day free trial or try their new forever free tier that's super generous. Head to cockroachlabs.com/changelog to learn more. Again, cockroachlabs.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Thanks to our friends at Manning, we are giving away a free ebook copy of 100 Go mistakes and how to avoid them. Stay tuned until the end. Matt will tell you how you can win. It should be pretty easy, but you do have to pay close attention to what Mark says on this episode, which may be a sacrifice you're not willing to make. All right, let's get on with it. Here we go.
Hello and welcome to Go Time. I'm Matt Ryer and today we're talking about how to make mistakes in Go. Why would you want to make mistakes? Well, I'm glad you asked. Tell us then. I will if you don't interrupt because I will get on with it. Right, so we all make mistakes and they can be a great way to learn. So that's why we're doing this episode. We're going to hear about some common mistakes that are made or if you're a brilliant programmer and you want to make more mistakes, so that you fit in better, This is the episode for you. We're joined by the author of Manning Books, 100 Go Mistakes and How to Avoid Them, Teiva. Hello, Teiva. Welcome.
Hey, guys. Thanks a lot for inviting me. I'm a big fan of the podcast. Yeah.
Oh, nice. Then you can stay. We're also joined by regular co-host Johnny Borsico, isn't it? Hello, Johnny.
Yes, it is, isn't it? Hello.
Hello.
Wow, this whole show's turning into a mistake. Can we start over?
No, we can't. It's live. It's recorded live. That other voice you heard, and this may be my mistake, but we've invited Mark Bates back. Hello, Mark. Welcome.
Hello. I don't think you can talk about making mistakes and Go without me being president.
Yeah.
President or president?
Maybe
either
both.
one.
Mistakes. Yeah.
Maybe both. I'm really good at it.
Yeah, exactly. And that's
really good at it. Matter of fact, 99 of TV's examples are from my repos, which is kind of nice. I feel very proud of that.
Source material.
Great. Well, let's dig in. Teiva, maybe you could just kind of tell us about yourself first. You're an engineer at Beats, right?
Yeah, indeed. Software engineer in a company called Beat. You can visit it on thebeat.co. We are in the ride-hailing domain. And by the way, just the small part at the beginning, we are recruiting people and we are doing a lot of Go, a lot of cool stuff. So if you want to take a look at it, please do.
Brilliant. Okay. Yeah. No, feel free to, if you want to plug something and use the platform to plug something, feel free. Don't have to ask in advance. No problem.
Bitbar.
It's changed its name now, Johnny. Come on. I want to also do a quick shout out to Lagos Gophers, which is a Go community in Nigeria. We're doing a regular section, shout outs, where we shout at, because that's what Johnny said last week.
Do we just yell at them?
Yeah.
Is that what we do? That seems awfully rude.
Hey, Lagos! Nice one!
Niger.
So if you're in the area,
Yeah.
in Nigeria, then, head over to it. Okay, great. Right, so, mistakes. Let's see. Teiva, I asked you to pick some of your favorite mistakes that we could then talk about. So maybe you could pick, we can go for the first one and tell us what was the first mistake you picked?
The first one I picked was related to nil receivers, because I believe it's a very common one. Many of us have already experienced it, and if you don't, at least I hope that it will prevent you from doing it, right? Mm-hmm. It's a mistake that I have already seen on a project I was working on, and basically it was something related to returning a nil receiver. So let's take here as an example, I have a concrete example where we can say, I am going to implement a validate function, for example, right? That validates an HTTP request or something like this, okay? And we don't want to return only the first error we met, right? We would like, for example, to convey that the validation error, convey multiple errors, right? So there are different schools of thoughts here, and one of them being, for example, to either return a slice of errors or just return a custom error type, right? And here we will take the example of returning a custom error type. So we can create, for example, a custom struct called multi-error, let's say, that can contain some different fields and everything. And more importantly, at some point, it contains a slice of errors, right? That we want to kind of mutate throughout the errors. So we take this multi-error struct, we make it implementing the error interface, and it's a pointer receiver because the slice needs to be mutated. So in our validate function, what one guy could do in that case is to say, first, I'm going to create a variable called result, okay? It's going to be a pointer to multi-error, so I write var result star multi-error, right? And by default, result is going to be assigned to nil, as the zero value of a pointer is nil, right? Yeah. So let's say that we implement the whole function, we do the sanity checks, and if there is an error, we mutate result to append a new error. And eventually, in the end of the function, we say, I am going to return the result variable, right? So in the end, result can be either nil, if we face no errors, or it can be a pointer referencing a multi-error instance, right? So let's now say that we implement the consumer side, we called our validation function, and we check whether the error is nil or not, right? And here, surprise, the error is never nil, actually. Even when we faced no errors, the error itself that we return is never nil. So what happened in that case? We have said that eventually we were returning the result variable, right? So if there is no error, actually what we are going to return is a nil receiver, not a nil value directly. And as the return type was an interface, because we return an error interface, right? We didn't return a nil value here. We return an interface implemented by a nil receiver, which is actually different from nil. And that's why on the check on the consumer is never nil. And just for information, why do we have this? It's because in Go, a nil receiver is allowed, which might sound a bit odd at first, but it's actually allowed. And the reason is because a method in Go, it's just some kind of syntactic sugar, just like if the receiver was actually the first argument of a function. And it's actually allowed to pass nil arguments for pointers, right? So a nil receiver is completely allowed. And if we want to fix it in that very case, instead of possibly returning a nil receiver, we should return a nil value directly. So eventually in the end, we could do if result equals to nil, return nil instead of returning result, right? And it's actually the same on the consumer side. I mean, on the other side, if a function accepts an interface and we pass to it a nil receiver, not a nil value, the variable assigned to this interface won't be nil. So just as a small conclusion here, when a function accepts or returns an interface, and that we pass or return a nil receiver, the variable assigned to this interface will never be nil. And in general, actually, having a nil receiver is probably something we never want in Go, and it means a probable bug, so it should be avoided.
Oh, yeah. So that's such an interesting one. How common is this? Because, first of all, if that happened to you, you'd be very surprised, I think, by that. Johnny, have you ever run into this issue?
Perhaps it's my general approach. I tend not to have custom error types that basically themselves contain sort of multiple errors, kind of like the example Teiva has illustrated. I tend to prefer a slice of errors over a custom type containing multiple errors, right? So I haven't run across this particular issue as laid out, but I can absolutely see myself easily stepping on that landmine as explained, because it would be a natural thing. I wouldn't be thinking, nil a value versus a nil, that's supposed to point to another type that just happens to be nil, right? So I'm not sort of slicing it that thinly, I guess.
Yeah. I've written code that allowed for methods to be called on the nil version of something. And it was just a kind of, usually it's a no-op or some default behavior. But is that too magic, do you think, these days for Go, Mark?
Yeah. I think so, yeah. I think that's definitely way too magic. I agree with Johnny. I'm well aware of this problem. We talk about it when we're teaching at Gopher Guides. But it's not something like Johnny. I think the way I write my code, I've never hit this particular error, and I almost never use custom error types. When I do, I use a slice of errors like Johnny kind of talked about. I don't know. I kind of write my code so that I never hit that. Francesc did a really good, I think it was a GopherCon talk about when nil isn't nil on this very same subject. So it does come up. It's a really good talk, obviously. It does happen all the time to people. It's a super easy, very easy way to find a bug in your code that will take you 3-4 hours easy to track down.
So I'm curious, what is the antidote? What is the advice that you present in your book, TV? Is it to avoid these kinds of situations, or is there a pattern or an approach to where you can still use that custom type?
Turn an explicit nil?
That's one way, yep.
Well, in that specific case, of course, the solution would be to return nil instead of a pointer receiver. But in general, okay, we discussed about returning an error and say, okay, perhaps I'm not going to create a custom error type here, but we may still have the case where we return an interface. In general, okay, in Go, we tend to say we shouldn't return interface, right? We tend to take rather the approach to say I'm going to accept abstractions, so accept interfaces, and rather return concrete types, right? Kind of be liberal with what we accept, and we don't want to force our function to force abstractions, right? But I believe that it's not a hard rule, because sometimes even you can see from the standard library directly, some functions returning directly an io.reader or io.writer directly instead of a type itself, of a struct, right? So I believe that we may still face the case where we have at some point to return an interface. And in that case, we still have to bear in mind that, nil isn't exactly the same thing as a nil receiver. So it's still something I believe that we can face.
Yeah. And why do you think this happened? Is this just something that emerged? Do you think this was a known thing when they were designing the language?
Well, I believe it happened again because it's in method in Go are particular animal. There are just some syntactic sugar, as I said. Yeah, but I don't have more insights on this one.
Yeah, I don't think it wasn't a concrete decision to allow or to have it do that. It was just more a matter of it fell out of the type system that way.
Consequence, yeah.
From my understanding of the issue is just that. It was something they obviously would have loved to have avoided because it is a bug, obviously, that hits people in a weird bug. But it was just more, it fell out of the type system and it wasn't necessarily designed into it.
Yeah. I never thought I'd say this, Mark, but you should be a little bit louder. Move a little closer to the mic, please.
I should be a little loud. I don't know why you don't think I'm loud.
It's just what I'm hearing.
Well, Maybe turn yourself up. You ever think of that?
Okay. Don't think that solves the problem. I think that makes it worse.
Here we go. Here we go.
Well,
I've got a common mistake in Go, working with math.
and that's from the president.
I was gonna save that for the unpopular opinions, but I think it's a popular one. So far, only David Hernandez seems to be able to stick around and hang in there.
Multiple times, too.
Don't use his name in vain.
Multiple times. I don't. I love David. God, he deserves all that he gets for putting up with you.
I love it. I've never had banter happening and insults concurrently for both Johnny and Mark at the same time. Speaking of concurrency,
we try.
Here's another one. Teiva, you talk about concurrency. Like, we feel like, Go is a bit famous for concurrency. It's got some great primitives that makes that so much easier to do than previous languages. Should you always strive to use that to make things concurrent, do you think?
That's a nice transition.
Yeah.
Thanks for that.
I've been professional.
I don't think I understand the question.
Is concurrency always faster?
Yeah.
That's the
question.
No. Next question.
It's not a quiz show, Bakes.
Well, it's a
okay, that's
fine. Continue on with your line of questioning. It was a yes or no question. Is it faster?
Yes.
No, it's not
Is it
always
a common
faster.
mistake that people make that people think concurrency is always faster? Teiva,
Did you just call?
you have to speak before Bates gets in, otherwise.
I keep seeing the setup. I'm
Why
like,
do you even have me on the show?
Teiva, jump in.
Okay, well. Okay, cool. Yeah, so I believe definitely it's the case. So, yeah, I believe that a common misconception from junior or even mid-level developer is to believe that a concurrent solution should always be faster than a sequential one. Because, well, if we implement a concurrent solution that leverages multiple CPU cores, it should obviously be faster than a sequential implementation, right?
Yeah.
That's a false affirmation. Wrong. No, and I believe actually that it's even more of a belief in Go thanks to Goroutine, as you have said, Matt, because Goroutine compared to threads are great. They are more lightweight. They are faster to spin up. They are faster to context switch and so on. So there shouldn't be like any real reason for concurrent application to be slower than sequential application. I took here as a concrete example, actually. I took as an example the merge sort algorithm. And just as a quick reminder about what the merge sort algorithm is, if we take, for example, the recursive implementation, we basically get a list of elements as an input. And we will break down repeatedly each sublist into two sublists, into two halves, right? We are going to do it repeatedly. And once we reach sublists of a single element, we go up again and we merge the two sublists in a sorted manner. So for example, a quick example, if we have 2 and 1, for example, we are going to split it into two halves, 2 on one side, 1 on the other side. And as each sublist contains a single element, meaning it's already sorted, then we are going to merge it in a sorted manner. So we will have 1 and 2. So in a nutshell, the merge sort algorithm, we get a slice as an input. We check the length of the slice. If it's bigger than 1, we compute the middle. We apply merge sort on the first half, merge sort on the second half, and then we merge, right? And so the structure, for example, of this algorithm seems like a perfect fit for concurrency. Because we could say, every time I can handle each half into a specific goroutine. So the first half in one goroutine, the second in another goroutine, and say I will introduce some form of synchronization at some point to wait for both goroutines, right? So if we implement this parallel version of the algorithm, I run it on my local computer with a certain number of elements. And actually this parallel version is about 10 times slower than the sequential version, right? And despite the fact that the parallel version leverages multiple cores, right? So it's more than 10 times slower. And what is the reason for that, if we think a bit about it? So as we say, the algorithm is about to repeatedly split lists into two sublists, right? So at some point we will have one 1024 elements, then 512, then 256, and so on until we reach 8, 4, 2, and 1 elements, right? And now let's try to imagine, in your opinion, like what's the fastest between spinning up 2 coroutines that will both merge 2 elements and wait for them, or in the current coroutine, merge 2 elements, then will merge 2 other elements. And of course, it's going to be the latter here, right? Because it's going to be faster to do it in the current coroutine. And if we think about it, actually, in the merge sort algorithm, the deeper we go, the less efficient it will be to spin up a coroutine. And sure, coroutines are fast, but spinning up a new coroutine, it has a cost because we have to wait for its creation. We have to wait for the internal Go scheduler to execute it. We have also the fact that concurrency introduces some form of synchronization because of mutex or channels or whatever. So everything, it has a cost, right? And here the solution, one possible solution for this algorithm, here the goal is not, of course, to design the most optimal solution for the merge sort algorithm, but discuss about a potential solution. It could be to say, I will define a threshold and I will apply the parallel algorithm that we just described, but if the number of elements is below a certain threshold, it's simply not worth spinning up new coroutines. So instead, I am going to execute sequentially. And this threshold, so okay, may depend on the machine and everything. So on my side, it was about 2048 elements. And if I run this new hybrid version, let's say, of the parallel algorithm, it's about 40% faster this time compared to the sequential implementation.
Yeah.
And one very last thing to say, I have done the same test in Java, actually, where we don't have the principle of coroutines, right? We just have threads here, right? And the threshold actually was higher. It was around 4 times bigger, if I recall correctly, compared to coroutines. So it's kind of interesting because somehow it shows that coroutines are actually somehow more efficient than threads for concurrent workloads because they are, for example, faster to spin up. But as we illustrated with the merge sort algorithm, it's not magic nonetheless. Concurrency isn't always faster.
This episode is brought to you by SourceGraph. SourceGraph is universal code search to let you move fast, even in big code bases. Here's CTO and co-founder Byung Lu explaining how SourceGraph helps you to get into that ideal state of flow in coding.
The ideal state of software development is really being in that state of flow. It's that state where all the relevant context and information that you need to build whatever feature or bug that you're focused on building or fixing at the moment, that's all readily available. Now the question is, how do you get into that state where you don't know anything about the code necessarily that you're going to modify? That's where SourceGraph comes in. And so what you do with SourceGraph is you jump into SourceGraph. It provides a single portal into that universal code. You search for the string literal, the pattern, whatever it is you're looking for. You dive right into the specific part of code that you want to understand. And then you have all these code navigation capabilities, jump to definition, find references that work across repository boundaries, that work without having to clone the code to your local machine and set up and mess around with editor config and all that. Everything is just designed to be seamless and to aid in that task of code spelunking or source diving. And once you've acquired that understanding, then you can hop back in your editor, dive right back into that flow state of, hey, all the information I need is readily accessible. Let me just focus on writing the code that implements the feature or fixes the bug that I'm working on.
All right, learn more at sourcegraph.com and also check out their bi-monthly virtual series called DevTool Time, covering all things dev tools at sourcegraph.com/devtooltime.
So a couple of things there. One is like when you're sharing data, when you're working on the same data, you have to be safe concurrently. So you have to then lock usually, and things are going to be waiting. So that's always something to consider. And then I guess, Johnny, you benchmark things, don't you? That's how you find out these little
Yeah,
things.
exactly. That was going to be sort of my again, in the same spirit of my previous question, like how do you find out, right, what the right sort of threshold is, right? Other than if you benchmarking, it's doing some profiling work and figuring out, okay, where is the diminishing return? Where is that point?
Yeah. Yeah, that's it.
It's interesting, we're talking about currency and we talk about what, how sometimes concurrency is not faster, and this whole kind of idea. One of the biggest things I've noticed with newbies and anybody coming to Go really from any language is this like, let's make everything concurrent because we can. And you're demonstrating very empirically, hey, if you do that in the wrong places, you're actually going to hurt your app. But I see it a lot, not even from the numbers perspective, just from the architecture and the complexity that I see a lot of people introduce into their apps when they just have no need for it. And one of those is channels. They build in a lot of channel usage early on because they think they should. And then you're like, oh, actually, you only use channels like in these 3 occasions. So concurrency in Go, what drove us all to Go originally, I think. I know it certainly drove Johnny and I, being Rubyists before this, right? It drove us here, drove everybody else here. But then to sit there and say, hang on, just because we've got concurrency doesn't mean you should always use it. That's a different thing altogether.
Yeah, I think that's a good point. I was going to say also that the complexity thing, that applies actually across the board to any of these little cool features, particularly if it is like you're doing it for optimizations, you're doing it for performance reasons. In most cases, you're going to make your code more complicated and therefore less maintainable. So you just have to weigh that cost, Maybe it's worth it in your case.
Yeah.
And maybe it's not.
I often find when I'm building apps, I start serially. And then, because I start in the morning.
Have your cereal.
And then...
Yeah. No, that's fair. Yeah.
No, the too many dad jokes? Okay, I'll skip that one. Anyway, that one didn't work. That one's out of the repertoire.
That's a serial killer joke.
There's that too. I start, very serially. Like, I'm just going to start my program and I'm going to call my methods and my functions as need be. And I'm going to find, as I'm working and as I'm using this app, that I'm struggling all of a sudden here or there. I go in, I benchmark or I profile and I say, oh, you know what? This bit of code here would really benefit from being concurrent, but not the whole thing, just this section where there's a lot of process, a lot of stuff happening, and we can get a big win there. But I only do that once I know that I'm getting that from the testing and the benchmarking.
Yeah, I think that's great advice. Chris James from the Go for Slack channel Go Time FM, and by the way,
long-time listener, first-time caller.
And by the way, please join in the chat. That's where we hang out. Chris has a question for the lads with a Z. Chris says, one of the strengths often touted about Go is that because it's very simple, it's more difficult to make mistakes compared to other general-purpose languages. But as we are learning, there's at least 100 mistakes you can make, if not more. Does the panel have any ideas on changes to the language that could or should be made to reduce developer mistakes? And kind of shadowing springs to mind for me on this one. I feel like if...
Shadowing, definitely the magic OK is another one.
So
those are for those of you who kind of know what I'm talking about. You kind of get the map. Map returns this random OK, Boolean second variable if you ask for it, or if you're doing a type assertion, right? If you ask for the second random option value that's there, that's and these things I don't even think they're documented. You just kind of know that they're there, and none of us mere mortals can add them. The Go team can add them in like weird places. Like, why isn't type assertion? And that's one of my big ones. Why does that not force you
check if it's okay or not?
To check the okay, because the alternative is a panic, right? And I see that all the time. I see type assertions constantly in the code without that okay check, and there's just panics waiting to happen. And if I want to panic, I can panic, even with the okay. Right. But I also think panics shouldn't exist, but that's another language change I think that could solve a lot.
And do you think that I mean, that generics is going to be a nice use case for that. Instead of having to cast every time that you will have to handle generic set of data or something like this.
In some cases,
Generics.
but the thing is, it's if you're dealing with data that comes in from JSON or something, often that's when, because sometimes you have generic data, so you don't have structs to demarshal it into. You have maps of string interface. And then if there's an object inside an object, that becomes a map string interface too. So you sort of, in that case, you have to rely on that. So in a way, in some cases, probably not. But I don't know. What were you going to say, Mark? Do you like generics?
What I was going to say is I grew up, my first job, I was writing Java, and we didn't have generics.
Oh, right.
Then I went to Ruby, and we didn't have generics.
No, nothing.
What was
How
that?
old are you? No, carry on.
I'm old. I'm old. My first job out of college was, anyway, I actually was doing ASP, so I kind of lied. I skipped
classic
the whole...
ASP?
Classic
Wow.
ASP.
Bates's
You go way
ASP
back.
was classic. Full of banter in the comments.
It was as classic
Funny
ASP
variable
as it could
names.
get.
Wow.
Oh, he had a blast. Absolutely
Good times.
classic.
Good times.
Now I can't even remember what I was talking about. Oh, programming generics. Thank you. And I've never worked in a language that has had generics to date, kind of built in as we know, as the term generics is known throughout the community. I have, as of yet, run into one area in particular where I'm like, generics would have been perfect there. I've been coding for over 20-something years professionally. So I think I like the idea of what generics can possibly do for the language. I'm also afraid of everything they can do to the language.
Yeah, okay. Well, we're going to find out, though. We'll find out together. And don't worry if you're scared by generics. GoTime is your friend.
Well, because I can see performance problems, right? Because we're just talking about people coming to Go and abusing concurrency. And let's be honest, that's what we were talking about. We were being very nice about it, calling it a mistake, but
Right.
it's abusing the technology, right? And we all did it when we first came. New people come and they do it. And that's the mistake, is we keep abusing it, right? But I see that mistake about to happen again with generics. And I can see everybody rushing to implement everything in generics. And I can see programs crawling to a halt because everything's super slow. And like tools that are, parsing things and working, in all these different ways and Go are now going to be not supported or working incorrectly because of generics, or they need to be able to. I just see a lot of potential, mistakes coming down the, if we're going to keep using that term, mistakes coming down the pipe here.
Yeah.
I take a more optimistic view.
Thank goodness.
No, I mean, I do see the same dangers Mark sees. I guess I'm choosing to look beyond what happens after the initial, spike and all sort of the abuse.
Yeah, but that's going to be the first couple years.
Right.
And those couple years are going to stick with us for 5 or 10 years.
Yeah, I mean, there is
Still
some of that.
optimistic, Johnny? Still feeling optimistic?
No, I'm no.
And climate change, Johnny. I mean,
look, the way things are going, we won't be around maybe to see the change after the spike.
that's a good point. I shouldn't worry about generics because climate change is going to take care of the problem.
of everything.
I'm still worrying about modules. I don't have time to worry about generics.
Wasn't there an episode on that last time?
Yeah.
Yeah, I think we hit that, right? Yeah.
They don't let me on those episodes anymore.
Johnny, are there other kind of common mistakes that you've seen?
Well, I can give you one from personal experience,
Yes, please.
which actually dovetails quite nicely with the very thing we were just talking about with the sort of the abuse of concurrency, right? So when I first came to Go, and my previous language before that was Ruby, and basically I was like, oh, this is so easy to do concurrent stuff, right? So I started sprinkling it on everything, right? And I was like, ooh, channels. How do I use? You don't need to, for those who don't know, you don't have to use channels to use Go concurrency, right? They're a communication medium, right? It's a synchronization medium, right? So you can have simpler mechanisms like a wait group or things like that. So you don't have to use.
In all fairness, I don't mean to interrupt Johnny, but I'm going to.
Cool. Well, go right ahead.
Early in the days of concurrency, we only had channels. We didn't have a lot of the other
True.
primitives for controlling things like wait groups, air groups.
Those came after, yeah.
context,
sync package, yep.
context and stuff like that. So all of the early documentation and all those early blog posts and videos, everybody's like, you got to use channels to start and stop Go routines and keep them in sync and protect mutexes or
Who's
whatever.
that
But
voice
anyway,
doing?
go on.
Yeah.
You like that?
That's his grumpy old man voice.
My normal voice is my grumpy old man voice. That was my grumpier old man voice.
As he climbs in age, everybody.
That's what I'm going to sound like in 5 years.
Right. No, but the personal experience is one where basically, I was actually in charge of building this sort of a batch sort of job thing where I'm communicating with some remote endpoint and making multiple API requests. And for some reason, there was no batch sort of, API endpoint to hit to give you a bunch of stuff. You kind of had to make, singular requests, if you will. So I'm like, hey, Go-routines are great for that, right? So I basically, I do testing, not always test-driven development, but I always test my code. There's a difference. We'll get into that later. But I write my mocks, I have my stubs locally and everything else. I'm sort of faking the API response and, I'm throwing Go-routines at it. Everything's going perfectly, right? Everything just works, right? And then I put the thing into production, and then all of a sudden, right, those hundreds of Go routines, perhaps even thousands of Go routines that I was launching to hit my, during testing, this mock endpoint, now it's actually reading a real thing. I start seeing a bunch of 429s in HTTP status code in my logs. I'm like, what's going on, right? For those who don't know HTTP status code, 429 means basically you're making too many requests. The server on the other side is saying, no mas, I'm not going to bother responding to you because you're simply abusing this API, basically.
Oh, your code was too good.
Well, perhaps not sensibly written, right? Again.
So what did you put a sleep in before each one? Random sleep.
Yeah, just
that fixes it, doesn't it? Then that solves the problem.
Fixes it. Yeah, it was one of those things where I'm like, yes, perhaps too much concurrency, right, will bite you, right? So you have to factor in, which is something I also teach when I'm talking about Go concurrency. You have to factor in the constraints of your system. Like Go is not going to be your bottleneck. The language is not going to be the thing that makes your stuff doesn't go slow. Like your databases are going to be bottlenecks. The network is going to be your bottleneck, right? The third party endpoint you have to talk to, right, over the wire, that's going to be your bottleneck, right? Not the language. So factor in the constraints that you have to work with. What problem are you solving? What are the constraints that exist within that problem domain? The language itself, that's not your problem.
That's, we teach the same thing at Go for Guides, I mean, that's one of the nice things about Go, right, is for 98 or even higher % of us, the language has our back in terms of performance and just making sure we're not shooting ourselves too badly in the foot, and it's the database, it's the network, it's the file system, right? Those are the things that are going to make your app just crawl. It's not going to be that little bit of business logic you have in validating a struct to make sure that there's an email address and a first name, like those,
right.
Like all that sort of stuff. It's the network calls. It's your database, which is just a network call unto itself. And that's all a database is. Or you're calling the file system, if it's which is just even worse than the network half the time, right? So yeah, those are all real issues that I think people just kind of get in their heads, and they think the language, they need to fix it in the language and not kind of look at what they're programming and what they're coding and say, okay, let me focus on that and find those performance issues later when they become that problem. This is, I think, the second time we've come back to that kind of concept.
But it's an important one. It comes up a lot. It's worth bearing in mind as you're underway, as you're writing code. It is worth bearing in mind. Yeah. So, Teiva, there's also another one about time after. This is from the book. Time after, you can possibly have a memory leak?
Yep. So, well, not really memory leak per se, but having a peak of resource consumption in some specific cases, let's say. So just as a reminder, time.after that accept as an input a time.duration, right? And it returns a channel of time.time, right? And it waits for the duration to elapse and then sends the current time on the return channel. And most of the time, it's also used in concurrent applications, let's say, because of the handy channel. Otherwise, if we just want to wait some time in the current Go routine, we can just use time.sleep, right? So let's say that, let's imagine we want to implement a kind of smart consumer, I don't know how to call it, that will keep receiving messages from a channel, right? But let's say if we don't receive any messages for, let's say, 1 hour, we also want to log a message, right? To log an alert, for example, or something like this.
Yeah.
And one way we could implement it is using time.after in this case, and we could say, I will have a for loop with a select inside and 2 cases. And in the first case, I'm going to receive messages from the channel and then call a function, do whatever with this, the message we have received, right? And in the second case, we are going to receive on the channel that is returned by time.after to log the alert. I haven't received a message since 1 hour, right? Yeah. So in that case, let's say we just deploy our application, we keep receiving messages, that's great, but we notice that it consumes more and more memory and it seems to steadily increase actually. So what's the reason actually for that? We have to know that in every iteration, Go will actually evaluate time.after and it will create a new channel. And we may actually expect this channel to be closed in every iteration, but it's not the case. Actually, the resources that are created by time.after, including the channel itself, they will be released once the timeout expires, right? So in the worst case scenario where we keep receiving a high volume of messages, we will keep looping, we will repeatedly call time.after in each iteration, and it will keep creating resources until the duration, in our case 1 hour, elapses basically.
Yeah, now I have definitely made this mistake. Doing exactly
Wait,
that.
hang on. I'll be right back.
Yeah.
I gotta go fix something.
Yeah. Yeah, I mean, and so the answer must be to create the channel outside. What's the answer? How do you avoid that?
There are different solutions. One of them could be to say, I can use context.withTimeout, but it's not perfect nonetheless, because it would mean that in every iteration, I have to call .context.withTimeout, and it's going to create a channel. It's not lightweight. Here, the most appropriate solution could be to use within the time package, the timer structure.
Yeah.
The timer structure, basically, we can create it with timer.newTimer, where we pass a time duration, and internally it has a channel field that we can access. It's timer.c, and it has also a reset method. And the reset method, that's going to reset basically the duration. So what we could do in our case, we could say, okay, before to loop, I'm going to create this timer. In the second case, I'm going to listen on the timer.c field, which is the channel, right? In every loop iteration, I'm going to call time.reset to reset the duration. And here it will just reuse the same channel, basically. So it won't have to create a new channel. So that's probably the most appropriate solution here.
So is it possible to use time after in a safe way then? Or should we just avoid it altogether?
I believe if we are in the context of a function that keeps being called, be it in a loop, for example, or we can have also the case in an HTTP handler, right? Because in an HTTP handler, if we call time.after and that we keep calling this HTTP handler, we may have the same case, right? So my recommendation here is probably to not use time.after when we are in a context of a function being called repeatedly, right?
Yeah, that's a good one.
Nice.
Yeah, that is a good one.
Very good one. Yeah.
This episode is brought to you by our friends at GitLab. GitLab is inviting you to attend GitLab Commit 2021, their upcoming user community event, August 3rd and 4th. It's free, it's virtual, and everyone can attend. Learn more about modern DevOps and how it transforms companies of all sizes and pushes teams to drive innovation to market. During this 2-day conference, attendees across all time zones will learn how they can instill modern DevOps practices at their organizations through in-depth trainings and workshops, hear firsthand stories from some of the most well-known companies, and gain insight into cutting-edge CI/CD and security technologies that bring companies to the next level. Get ready to innovate together during this free event designed to help you to commit to better DevOps. Register and learn more at GitLabCommitVirtual2021.com. Once again, that's GitLabCommitVirtual2021.com. or check for links in the show notes.
Bates, you were talking earlier about another common gotcha.
Yeah, I was.
To do with the API footprint that you export.
Oh, and by talking about that earlier, you mean in the private message I sent you this morning, completely offline and out of context of this call.
You weren't talking about it earlier on this podcast. It's just a mistake. It's part of the theme of the show. I'm going to be making lots of mistakes.
I love it.
No, please,
I love
John,
it.
go
Yeah.
on.
So. So yeah, well, Matt obviously asked us all to submit kind of common mistakes that we see a lot.
Telling him how we do
One of the
it.
ones.
Just do the thing. Don't tell him how we've done it.
Well, mate, it's not that big a deal.
Exactly.
I don't, the sausage is being made
It's just a
here. Right?
That's the problem, though. Is I want them to think this show is way more sophisticated than just me texting you while you're having your cereal.
Well, that would be his mistake now, wouldn't it?
Well, exactly. Anyway, one of the things I see new developers to Go do a lot is basically export everything. Everything starts with a capital letter, and that's it. Like their entire package, all of their types, every field in their type, every method on their types, everything is public. And of course, when you do that, you can't take that back now. You can't, that's it. It's out there as soon as people start hooking into it. And I feel, modules have made this problem a little more complicated in some areas, but it's definitely one of the big issues I see where people should be starting with everything unexported and only pushing up those pieces that they need. I think it's a lot to do with just people misunderstanding the way Go does exporting and unexporting, because it's different than every other language I've used. This whole idea of capitalization to infer whether it's public or private. I love it now that once I got it, I'm like, oh, that's brilliant, because I can look at anything in my system and immediately know whether it's visible or not. Right? I'm not scrolling up to look for a private or protected method above it. But at the same point, I think new people come to the language and they see things that are uppercased or whatever, and they think, I'll just uppercase everything because it's a proper word. It's the user's struct, so therefore you must be capital U.
Right. So would you say that people should just by default use lowercase letters everywhere until you then need to export it for some reason?
Yeah, I mean, you'd have to sell me on why you would want to do it the other way around. There are definitely types when I open up a package and I go, this type has to be.
Because you're thinking about the use of that package.
The actual API.
Because I know what the use of this package is, right? But, so I'll say, okay, my user type I need to export because I need other people to use it. But the fields may or may not be fully exported, right? Or the methods might all start as unexported methods until I need one to be promoted. I needed to use it outside the package. And again, it's like, well, do I need that method or do I need something similar to that method that might be better, well-coded X, Y, and Z or somewhere else, right?
So, you know what you just made me think of? It wasn't a deliberate choice.
I'm glad this is coming out of your mind and not mine. Go on.
Yeah, now that I think about it, it wasn't a deliberate choice. It was more of a, I don't know, maybe I'm sort of adopting some of Mark's grumpy old, dude sort of persona. But I was like, my interfaces, right, inside of my packages, I don't export those at all because I don't want the consumer of that package to have a dependency on my own abstractions and my own interfaces, right? So it's almost like I say, well, if you want to create abstractions or whatever it is, you create your own interface, create a local interface to you, right, for whatever I'm going to, hand over to you. But I don't tend to rather expose my interfaces for my packages. It wasn't deliberate. It just kind of happened.
Oh, amazing.
I do expose a decent amount of interfaces, but I also write a lot of local unexported interfaces inside of another function or method sometimes.
Right, in line. Yeah.
Yeah, just inline because I want to check, does it have this method on it? And if so, I want to call it, and I don't need some big interface somewhere else. I can just do it right there in line. And that's one of the nice things about Go is that you can do that sort of thing. But that's an advanced feature, Johnny. That's a feature that I don't know about you, when I teach, I teach a lot of intro to Go at Go for Guides, and interfaces is one of those things that people really struggle with coming to Go. It surprises me because they're on the surface relatively easy. Like there's not a lot to them. It's a collection of methods. You either implement those methods or you don't, right? But people really struggle with that, and they struggle with the implicit versus explicit declaration of an interface. I'm not impling, this isn't my foo impl of this interface, right? And then they certainly don't realize that you can create inline unexported types and interfaces like inside of a method to make your life even that much more easy there.
Right.
Yeah, one downside to that technique is you can hide things inside the function. It's not always obvious that, you have to use docs or something to say, if it implements this interface, then it'll have this different behavior. So it is quite an advanced case, I think.
It very much so is. I use it mostly in an exception case where I've got an error or something, and I want to try to see if I can inspect a bit more information out of this thing, if I can. Otherwise, if I'm letting people know that I'm supporting these methods via interfaces, then I'll expose those interfaces more for the sake of hanging documentation on them. That, just saying like, hey, this method's going to take these 5 interfaces. So it's a documentation thing versus a required to be passed in.
Well, it's that time again. Teiva, hold this bass. Johnny, you're on the drums. Bates, pick up the guitar. It's time for Unpopular Opinions.
I actually think you should probably leave.
Who's got a meaty unpopular opinion? I said it wrong.
I do. I'll fire the first salvo.
Okay. Okay.
That came out of nowhere. You look surprised.
Yeah, I was surprised.
Yeah, I don't often have unpopular opinions.
I know. Because you're nice. That's what we were saying earlier, Mark, privately in a text.
Well,
That's what we were saying earlier. Yes, we were saying what a nice guy Johnny was. That's it.
Don't you think
Well,
Mark
thanks.
Bates looks like he's? Don't you think Mark Bates looks like he's just got back from being shipwrecked?
I made fire.
I've been stuck on that island for so long, thinking about generics and stewing away.
I'm like Curly from Lost. Somehow I gained weight being stranded on a desert island. I'm not quite sure how that happened.
No, you look great though, mate. Really. My beard's only
thank
jealous.
you. Like, that's your unpopular opinion.
Yeah, well,
I assume.
we'll ask.
that I look good, because that is definitely an unpopular opinion
You
in my
definitely
house.
would make a good Guess Who character from that game Guess Who. Like, way more interesting. Yeah.
Fair enough.
Can I opine now?
Please, Johnny,
Is it
I'm
okay?
sorry.
Yeah,
Please.
go for it. Please
Okay.
help us.
I have to break this up. Oh, all right. And for those who don't know, this is actually what happens in real life too. Yeah. It's hanging out with these
Apart
guys.
from, I'd be getting a piggyback off Bates by now.
That's true. And there's usually a lot more food involved.
Yeah, and alcohol. Yeah, sadly. Anyways, so my you guys. All right.
Still waiting on you,
I know.
Johnny.
I'm
Still
trying to
your
get it out. Y'all keep making me laugh. All right. So here it is. Here it is. I think everybody coming to Go should make as many mistakes as possible. Because that's how you learn. That's how you learn.
I don't think that's an unpopular
Well, I've
opinion.
never heard that.
I'm going to disagree with you.
What?
Because I think the adage of making mistakes is like, people know that you're supposed to learn from your mistakes, and mistakes are good. So don't go and purposefully make mistakes. I don't know how you'd even do that, because they're not mistakes. Then you're just breaking your code.
You must
because
know.
you're like, Johnny said I should make my code terrible. I should introduce as many bugs as possible if I'm going to become a better Go developer. That's not, I think, what Johnny was trying to say, I hope. Because that really would be an unpopular opinion. Johnny says, do a terrible job at work and you'll become a better Go developer.
Break all the things. No. So here's some nuance. So here's some nuance. So I don't know about y'all, but when I'm learning something, like, maybe on the job, or, if I know that at some point somebody's going to look at whatever it is that I'm trying to do, like I go into this sort of learning paralysis where I just keep learning and learning and learning and reading and reading and watching, just consuming everything I possibly can so that the first piece of code I write has to be perfect. Right? Because I'm so sort of sensitive to the criticism, right? Over time, I've sort of learned to sort of feel less of that sort of, I guess, pain or feeling of inadequacy and whatnot. But like, I will spend a ton of time just becoming an expert at something without like actual practical knowledge that actually does make you an expert. So don't be in a learning paralysis sort of mode, right? Like, put stuff out there, make mistakes, talk about it, right? It's okay if, this is the internet. You will find a jerk that says, hey, this stuff is crap. That's fine. Brush it off, right? Most people are not like that, right? So don't be paralyzed, right? Just make mistakes in public. Learn in public. That's okay.
And that also extends, like, we should be forgiving as well when we see people making mistakes. Like, when you give that feedback, do that in a way.
Don't be that jerk.
Yeah.
Yeah, don't be that jerk.
Do it. Yeah.
We all do it. Johnny, I think you and I have very different coding styles. Because, well, you said, like, I want to learn something new, and what I'll do is I'll go and I'll find something that says, like, this is how you get up and started to Hello World, and that's usually where I drop off, and I just start coding and just, like, start hacking and, like, throwing things in, like, well, that didn't work, what the hell? And, like, so I, personally, that's the way I code. When I'm learning something new anyway, like, if it's a brand new tool, a package, a library, some concept I've never done before, I just write code. I can't just read and read and read. I got to just bang it out until I get to a point where I go, oh, that worked. That worked. Yay. Now, how do I make that clean and good and do what I actually want it to do, not just I got it to make a connection and return hi to me, great. Now let's take this and try to build
you
on
can't
that.
really,
So,
you learn so much by building the real thing. And this also speaks to like software engineering generally. We want to design it all up front. Sometimes we want to know exactly what it's going to be so we can do good estimates and things. You learn so much by doing it. So get on and do it. You'll just make so much more ground, and making mistakes in that sense is great because that really is how you find out what the real thing to do is. Sometimes it's impossible to know upfront, isn't it?
yeah. I'd say 9 out of 10 times I run tests, they fail.
Yeah.
And I'm okay with that most of the time. There are times when I'm like, why the hell are you failing? But most of the times it's like, yeah, okay, still not there yet. I just got to keep, that didn't work. What can I try now to get this test to pass? Like, we don't just keep making those mistakes till you find it. And that's
absolutely.
okay.
Well, speaking of mistakes, Teiva's book, 100 Mistakes, is...
Are you saying that his book is a mistake?
Goodness, we treat our guests
Matt,
better
you're
than
doing
that.
a terrible job. I think it's a wonderful book. And despite what you say.
Teiva, don't believe what he says. Yeah.
Teiva, man, Matt's
great
just
book, great
he's
work.
Jealous.
That was rude.
Your stuff is not a mistake.
That was rude.
Jealous. His Blueprints book hasn't sold well in years.
Of course it has. It's absolutely full of mistakes.
He's just, yeah, that's why it hasn't sold well in years, Matt.
You can find out for yourself by buying my book and also getting we've got, Bates, let's try this, Bates.
You can go to my torrent site and just download his book for free.
That's how we treat friends. We just put their stuff.
I'll put the link up on Twitter after the show.
Good. Thank you for putting it there so nobody will see it.
Eventually.
Bates, pick a number between 34 and 36.
Oh, I hate the way this works. 42.
No, a number between 34 and 36.
I was told there wouldn't be
Maths? It's not really maths, is it? 34 and 36, there's only one option, mate.
Yeah, 35. Okay, 35.
35%. We're going to give a 35% discount to anybody that wants to buy Teiva's book using the secret code PODGOTIME21. That's PODGOTIME 21. And we're also going to be giving a free copy away as well, Teiva. This is very nice of you to do this. So if you can tell me what title did Mark Bates give himself by mistake earlier in this episode, it's The Something of Mistakes. He gave himself this very grandiose title, as we've come to expect from Mr. Bates. If you can tweet what that is, we'll pick one over the next week. Tweet at GoTimeFM the answer to that, and we'll send you a secret code and you can get a full ebook of 100 Go mistakes and how to avoid them. That's good, isn't it?
I like that. It is.
Bates?
I like that.
That's cool.
I'd read that book.
You're going to try and win, aren't you?
I mate. I'm not quite sure what I called myself. Actually, I think I
back.
But I just didn't think you'd say that on the air, so I'm surprised.
Well, we'll see. Hopefully, it has to make it in. I'm only saying it so it makes it into the podcast episode now. I've made it part of the format. And that's how you do it.
It's gotta be. It's gotta be.
Teiva, thank you so much for joining us. Absolute pleasure to have you here and learn about mistakes. And good luck with your book. We'll look forward to reading it. Johnny Borsico, always a pleasure. And Mark Bates was also here. Goodbye.
Thank you.
Thanks a lot.
We have a bundle of awesome podcasts for you at changelog.com. That includes our brand new show, Ship It, with Gerhard Lazou, a podcast about getting your best ideas into the world and seeing what happens. It's about the code, the ops, the infra, and the people that make it happen. Yes, we focus on the people because everything else is an implementation detail. Subscribe now at changelog.com/shipit or simply search for Ship It in your favorite podcast app. You'll find it. And of course, the Galaxy Brain move is to subscribe to our master feed. It's all Changelog podcasts, including Go Time and Ship It, in one place. Search Changelog master feed or head to changelog.com/master and subscribe today. Go Time is produced by Jared Santo with music by Breakmaster Cylinder. We're brought to you by Fastly, Launch Darkly, and Linode. That is our show for today, but we'll talk to you again next week.
Okay, brilliant stuff. Thank you again. I mean, this is it. We've done the podcast.
Thank you.
Editors will turn that into something that sounds really professional.
Okay.
Right.
Believe it or not.
They'll just cut out all the parts Matt was speaking. That's usually how they do it.
You nearly said Mark as well. I love that.
No, I said
just gonna be like-
Mark and Matt. Yeah.
Oh, yeah.
So it's just gonna be 45 minutes of Tuvia speaking,
Yeah.
and that's it.
That's probably
it,
what
just
people
him.
want anyway.
That's probably a much better podcast than what we just did.
Yeah, it's
Next time, Teiva, you just do it. We'll just
more like the audiobook version of your book. You could just read it with your accent. That's the thing. People love accents.
That's cool.
We're delivering.
Matt and I could do the audio reading of your book.
Say no, Teiva. Say no. Say no.
voices.
Say no.
And we do it for, a reasonable rate. Well, one of us would take the narrative and one of us would take the code. You
Yeah.
see.
Yeah. Can you
So one would be the voice of the code.
Like, have you ever heard Matt do the file path walk?
Rap. Yeah, that was my idea, mister.
Okay.
yeah, but would you read
Yeah.
the code in like a Stephen Hawking voice? Because it's kind of fixed width font.
Well, who says I'm reading the code? Why can't you? I want to do the narrative.
Okay. Yeah, you've got the sort of bouncy kind of voice.
You got to keep the people interested,
Yeah,
you know?
and I'll be just like reading out the code in a boring way.
Yeah.
While having some tea.
Exactly. See, Teiva, we got it all sorted out. You just send us a copy of the book. We'll get it to you in the mail by Tuesday. Today's Tuesday. End of day today. We'll do it by the end of day today. We're that good.
Yeah.
One take without having read the book. We'll just write down.
Mistakes were made.
That would be a mistake.
Many mistakes were made.